Very good afternoon, students. In the last class, we have discussed about accuracy, precision, and errors in the measurement. Accuracy and precision we have seen, and and their definition we have seen, but error we want to discuss in the details. So basically, if we want to categorize the error into the two broad categories, then we can categorize it into systematic error and random error. So systematic errors are those errors, they are either in positive direction, negative direction. Okay, वो it means that it may be positive, error may be positive, or error may be negative also. So there are various type of systematic errors. So first one you can see here is instrumental error. Second one is imperfection in the experimental technique or procedure, and third one is personal errors. So students, it doesn't mean that there are only three systematic errors. There are many more errors, but we are going to discuss only three of them. Understood? So instrumental errors, as you all know, suppose there are graduations on the scale of any device. Graduations means the calibrations, the readings which you see on the device. Let's say it is imperfect. For example, you take a thermometer, and a thermometer is showing a reading of 104 degrees Celsius. But if you take the standard thermometer up to the same level, it was exactly 100 degrees Celsius. It means that the reading it should have shown was 100 degrees Celsius, but it is showing, instead of 100 degrees Celsius, it is showing you 104 degrees Celsius. It means that there is error, 4 degrees Celsius error in this device, means plus 4 degrees Celsius. As you can see, the error is positive here, right? Positive error, because it is reading extra 4 degrees Celsius in this. But suppose it might be reading 90 degrees Celsius, it means that there would be minus 2 degrees Celsius error, right? So I believe now you are understanding how it is come to be plus and minus, positive or negative, right? So second type of systematic error is imperfection in the experimental technique or procedure. Suppose your procedure might be wrong. Suppose you have to read any reading perpendicular to the device, but what you are doing, you are having a slanted angle, then you are looking on the reading, then there would be slight inclination, so that you will get to know there is some much more reading or might be less reading. So there would be some kind of error if you perform some mistakes in the experimental techniques or procedure, right? Okay, for example, suppose you are going to measure the body temperature. So suppose you are just putting the thermometer under your armpit to measure your body temperature, but the temperature under your armpit will always remain lesser than your actual body temperature. It means that the procedure you have performed was wrong, right? Because it is giving you lower reading. Okay, so as you can see here, error is negative, right? I believe you all are understanding. And now let's move to the personal error. Personal error is committed by sometimes humans, right? For example, parallax error. Parallax error is, suppose just have a look upon a distant object and keep your one eyes closed, okay, and keep a pencil in front of your eye. Now close the open eye and open your closed eye. Now you will see the pencil will get shifted and your image will also get shifted, right? So these errors are happening just because your eyes have distance. You have two eyes and there is a distance between two eyes, right? So this is called the parallax error. We can omit this also. Okay, once you perform the experiment in the lab, you will be able to understand how you can omit this error. Now let's move to the random errors. Random errors are those errors whose source of error is cannot be recognized. Means random, you cannot recognize the source, which source is causing such kind of error. That's why you will not know what to deduct, what to add in the final result. So here we cannot remove this error. The problem with random errors are we cannot remove those errors. For example, suppose you are operating a device at particular voltage, but sometimes any fluctuation can come at any time, any noise can come, but the source of noise would not be known to you. It means that you are not knowing whether the fluctuations are high or low. Okay, so in the final result you would not understand whether you have to deduct, you have to add in the readings to get the correct results, right? So random error is the actual problem what we face, okay, and we cannot eliminate it anyhow, right? So I believe you all understanding this. Now student, I am giving you one more activity here, the least count error. Okay, least count error is very important for any device. So okay, so read it and give me in the feedback in the Google Classroom that you have read it. Okay, once you read it, just give me the feedback. Okay, I'm just waiting.